Our next presenter is Autumn Shackelford from the Planetary Sciences track of the Physics PhD program.
I am reverse engineering dirt from other planets so that we can better understand the formation and evolution of our own solar system. And I recognize that that is a pretty loaded statement to make. So in order to orient everyone, I'll go ahead and start from a more earthly frame of reference. The sun is constantly radiating outward into space, sending rivers of protons and electrons out past Pluto and into the Oort cloud. And we call this stream of charged particles the solar wind. Earth's magnetic field protects us from the solar wind by capturing and funneling these particles down into our atmosphere, where we see them as the aurora. But not every planet is lucky enough to have an atmosphere and a magnetic field to protect it. And instead of getting a free light show like us, they have to reckon with the fact that the sun is a deadly laser. The moon, Mercury, and asteroids are some of these unprotected bodies. They're constantly being bombarded on a global scale by the solar wind and these teensy tiny meteors called micrometeorites. Now, this erosion from space is called space weathering, and it's changing these planets all the time. But how do we even look at that change, and how do we begin to study something like that? Well, we can start with a sanity check, something we understand. Olivine is a mineral that is present on both the Earth and the Moon, and we know this from Apollo soil samples. So if we look at this black squiggle behind me, that big dip there shows the iron present within olivine's crystal structure. But that's for olivine from Earth. If we look at olivine from the Moon, we see that green line there. So the dip is gone. Where did it go? Well, it turns out that space weathering cooks the iron out of the olivine and redeposits it back onto the surface of the moon, which changes its chemical composition and physical look after a period of time. But how do we look at this for other planets that we don't have the privilege of directly being able to sample? Well, we can recreate the space weathering environment in the lab, and that's what I do. We take a material that we believe to be present on a planetary surface, stick it in a vacuum chamber and suck out all the air to make it just like space, and then we bombard it with lasers at energies equivalent to the average micrometeorite impact in the inner solar system. In 32 minutes, we can recreate millions of years of space weathering on any material we want. And this is really cool because when we visit these planets with spacecraft or look at them with telescopes, we can directly compare the results from that data to what we see in the lab. So right here at UCF, we are looking at the building blocks of rocky planets, and those same building blocks are the building blocks of the solar system itself. So we're investigating the solar system's history, and I think that's pretty stellar. Thank you.